Hello and welcome back to Datafied YouTube channel, where we discuss interesting data concepts. In this video, we will be going through a very important expression or function called the Lambda function in Python. Of course, this particular module or notebook forms a module in one of our data analytics courses we take here at Datafied Academy. So I will walk you through the learning objectives for the module and then the breakdown of the outline. In this module, we'll learn how to define Lambda functions, build and code Lambda functions, and apply Lambda functions to iterable sequences using the map and filter functions. Let's look at the outline. This video will be structured in this order. First, we'll begin by introducing the concept of Lambda functions. Then we'll look at the syntax, map function and the filter function. Let's start by looking at the introduction. Lambda functions, sometimes called lambda expressions, are small anonymous functions that can be expressed in a single line, unlike the standard functions in Python, which are defined using the def keyword, a function name, a function body, and a return statement. Lambda functions are defined using 1. The lambda keyword, 2. The function expression, and 3. The function arguments. Lambda functions make it easier to create quick functions to improve code readability. Imagine creating a set of small functions to be called within another function. Lambda functions allow a user to create these smaller functions in a single line without having to make a separate set of functions to be called. Alright, so that is a brief introduction to the Lambda function. Let's look at the syntax, the basic syntax of the Lambda function. Here I want to quickly review the syntax for various forms of Lambda expressions and the form they are called in Python. Lambda functions are made up of 1. The lambda keyword, and declaring an inline anonymous function. That is what the lambda keyword does. 2. The variable or variables that will be passed to the function, and finally the lambda expression. So here is the basic syntax. Begin by declaring or calling the lambda keyword, the variables or arguments that will be passed, and then the expression. Okay, to understand this syntax that has been displayed here on my screen, I would like us to look at some examples. We begin with this first example, which is the doubling the input value example. Here, what do I want to or intend to achieve? I would like to show you how this is done using the normal function for doubling the input, that is multiplying any input by 2, and this is how it will look like. Begin with the def keyword, def double x, in the bracket, and then return x squared. So this has to be in 2 lines, right? And when you run this function, you have this function defined. Okay, let's see how this function works. Whenever we call in double of any number, let's say double 4, and run this function, it gives you 8. All right, double 196, it gives you 392. So this is doubling any value that is being imputed into the function. This same function that is written in 2 lines, I would represent or implement it with the lambda function. Let's see how that looks like. So here is the same function using the lambda function. The lambda expression interpretation. So it means, let me just give the interpretation. For any input value x, so when you say d equals lambda x with full column x squared, what it means is for any input value x, compute and return x times 2. Now we assign this function to the variable called d. Of course, it's not necessary, but because we want to see how this works, so we assign to the variable called d, so that whenever we want to print out d, or whenever we want to call the function, we have to call it as we called double of x, since that's been assigned to d, right? Now when you print out D, just D without giving any parameter, any input, what we see is the reference of the presence within the memory. Alright, so let's try to see what the output would look like. Now I'm printing out D. It says, okay, D is a function main.lambda x. So this is a function, and if you want to call an input or you want to use it to evaluate a particular expression or perform the function by doubling a number, let's see how that looks like. So I'm going to call D of say 4, and D of 4 gave us 8, just like the previous function also did. And when we call D of 196 also, you see we have the same value as the previous function defined above. So with the same outputs or results, we're able to define the lambda function in just a single line, other than having a standard function definition in Python in 2 lines. Now let's see also how to demonstrate or call it the functions, which I've already shown here. I called the 2 functions. I want to double 7 using the function double, and I'm converting that into string after executing the call of the function. I'm also using the lambda function to double 7. I'll also convert it into string after execution of the function D of 7, and we observe that we have the same results for the 2 functions. Okay, also we can call the lambda function in this manner. Instead of assigning to a variable D, the function can be defined right away in a square bracket, and then you put in your arguments or your inputs in another bracket just after the function, and this works just fine. Can you see? Lambda x such that x squared, lambda x such that x times 2, that is, whenever you get me the inputs, whenever you get me any input x, multiply that input by 2. And you see how great this function can be. Very, very simplified form. Alright, now having said that, we would go to the second example, which states the squaring the inputs. Second example is squaring the input. So how do we squared an input? Here I've defined the lambda function as s. I picked a variable called s for the lambda function, and I tell the function, hey lambda, whenever you receive an x, please square that number. When we run this function, the cell, and then run this other cell to get the square root of 5, we have 25, all in one line. If this were to be done using the standard function definition in Python, all we would have done is to define the function, give it a function name. If you call it s, then you go ahead and call it s, and next we would write the function return, use a return statement to return the square of whatever input the function would accept. Here's a third example. We want to see how to raise an input x to the power of the input y, and using the same methodology, we have, I am assigning the function to the variable name p, and here we have p equals lambda x comma y, such that x is raised to the power of y. When you run this function, this time around, because I'm giving it 2 inputs, 2 arguments x and y, it means whenever I want to call function p, I have to call also assign 2 input 3, 2 or any 2 numbers. That will give an input of 9, because 3 to the power of 2 is 9. Alright, so having said that, I believe with this introduction, you now understand how to implement the Lambda function here in Python. Okay, so in the next video, I'll be talking about mapping and filtering, and how to use the map and the filter functions alongside the Lambda functions to actually perform some more calculations or functions implementation. I hope you enjoyed this video, and I hope you've learned something new. Yes, if you are yet to follow or subscribe to our YouTube channel, please do so to get notified whenever we post insightful and rich highly educating content of this kind. Thank you for watching this. I'll see you in the next one, where we'll be talking about the map and the filter functions alongside the lambda function. Do have a wonderful time. Goodbye.